Hi, this video is just a bit of guidance for drawings relating to Assignment 2 of DE4301 in terms of placing dimensions and deciding on where to dimension from and what considerations need to be made in terms of sizes and so forth. So this little part here is a sort of a clevis mount, maybe it could be for a hydraulic cylinder or something like that. And if we have a look at the way it sits in an assembly, it mounts on a tongue on this plate, and it's got three positions that it can sit in where the holes line up, so they'll line up there or there or there. And if we look at an end on, there's clearance on top of the tongue and the base sits on the plate, so I'll just shuffle that along a little bit. So you can see that surface there is bearing on the surface of the plate. So when we design this, we don't want there to be any interference here. There must be clearance. It must slide, and it must locate on these mounting points. The bolt must fit through the clearance hole here, and these are threaded, although they don't look like it, but they are. And whatever mounts on here will have a pin to run through this hole, and that should be probably some sort of sliding fit. So knowing the context of the thing, we can apply some sizes and indicate perhaps some machining tolerances and so forth that make the part useful. The top surface doesn't matter, so rough overall limit of plus or minus 0.5 would probably be sufficient. It might even, the bar stock might come this width, whatever this happens to be, we'll find out. Possibly not. And yeah, so the key really is not to make the part more expensive than it needs to be, but it must work. So if we close that out and make drawing from part, and I've got a template that I've set up for myself here, which has a few little features that we might just run over first. So I've put the third angle projection symbol in there as part of the template, and you would do this or have this done for you in any business environment, and chances are there would actually be a company logo and company name on the sheet as well. The other modifications that I've made to the sheet or to the title block, there's a bunch of other angular tolerances and so forth I've gotten rid of out of here because they could be added if required. Often just sufficient would be lengths, and I've taken the automatic labels out of here. They are useful if we save our files in a particular way by drawing number, but if we're not doing that, well then you will have seen on your own initial drawings that this can get a bit messy. I've changed it to sheet 1 of something. We can add a number in there if necessary. What else? It's about it really, but it just makes it a little bit more usable and a little bit less work each time. And I have had a query about this third angle projection symbol, which I think that rather than putting it as an item that you can add, I think it should be always present, because we are always going to be drawing any orthographic drawing and third angle. I guess if this was just purely a pictorial drawing, well then that would have to go, but most of the time we're not working off pictorial drawings. So if we pick the front view and place that, and it'll automatically project our three views. In this case, the part requires three views to show what it is. I don't think we need a fourth view other than our standard sort of pictorial that we tend to have on these sort of drawings because it's easy to do. Make that more solid, and that's fine sitting up there, and it leaves us sufficient room. I just might move these around a little bit, make use of the space that's available to us. Might have to shuffle these later on once there's some dimensions in place. So what I'm going to do initially is set the way that SolidWorks displays the dimensions to having no decimal places, because that will be quicker given that there's quite a few dimensions on this that don't matter too much. So if I just go into my tools and options, there's a few places to get to this, and document properties, units, and we'll drop that down to none. So that means that for the overall general sizes we won't have to adjust them. We will have to adjust the initial dimensions we put on because those are going to be the ones that we deem to be important. So focusing in on where there's two critical areas in this part. It's possible that the distance from the centre of this bore to the surface is important, and if it was, well then we would use that face as a datum. For the holes, probably the datum would be a centre line off of the part, but the critical thing is the spacing of the holes. So that's what we need to indicate on our drawing. So initially we'll put a centre line on here just by clicking the two surfaces. So there's that, and then if I dimension, I might actually just crack on and put another one on here. Yep, and say that's sufficient. And now we'll dimension these two holes, and I'm going to say that it doesn't matter where they are in respect to the outside boundaries of the part or outside surfaces. The centre line indicates that they should be on centre, and we're going to add some general tolerancing in a minute to set that as a tolerance. So this dimension here needs to be more accurate than just an overall, so we'll give it one decimal place, and what that means at the moment is nothing, but what we can make it mean is we'll put a general tolerance for the drawing. So we'll add a note in here, and say 0 is plus or minus, and that plus or minus sign you can put in by going Alt and then 0177. There's a lot of Unicode that you can add using the Alt key, and if you have a look on Google you'll find the various different options. So we'll say that if there's no decimal places, well then we'll make it plus or minus 0.5. and then if there's one decimal place, we'll make that 0.2. And if there's two decimal places, make it 0.05. Now these are all a little bit big in terms of fitting them into this little box down here, so we'll just escape out of there, and we'll change the font down here to 8 point, and then that will shuffle in quite nicely down there. So for this drawing we're indicating 0.5 millimeter, or it can also apply to the angles in terms of degrees as well. Okay, so we've got a size on here as well, so those bolts have to go through the hole. So if we go back to Smart Dimension, we need to adjust that a little bit, and we'll change that to 10.5, and with one decimal place that would be 10.7 down to 10.3. 10 mil bolt's going to fit in a 10.3 hole, so that should be okay, and the combination of that with the spacing should still ensure that we get alignment when the two parts fit together. So you've got to consider all the permutations of your dimensions. So the other part that's important with this is this slot. This is where this fits. Well, there's three actually, but we'll look at the slot first. So we'll dimension the width of the slot. And that's, depending on the way the tongue is dimensioned, I would suggest that what we would do with the tongue is we would dimension this at 16 millimeters plus or minus 0.05. That should be easy enough to achieve with a milling cutter running through it, and the tongue could be 15.9 plus or minus 0.05, and that would still give us clearance generally because the milling cutter is not going to cut undersize. So yeah, maybe I guess that could be size for size perhaps, so maybe 15.85 would be a size that we could make the tongue that fits inside there. Always, no matter what you're producing, you want to be focused on making sure that you're not making the thing any more accurate than it needs to be to operate. And this thing is going to have a hydraulic cylinder or a pneumatic cylinder located securely on some sort of surface. It's not really going to matter if that key's got a little bit of play in it because it's bolted down solid, but we want it to stay square. So it will be sufficient at that sort of tolerance, or that sort of clearance. So we'll just adjust that now, make that to 2. And the other part of this that fits is the depth. So the important thing here will be the surface to this surface here, and so we could argue that this bottom face for this view is the datum surface. The height of the hole to that surface is probably not that important, but just for the purposes of this exercise we might say that it is, and we could dimension that from that surface as well. So so if we dimension that height, and we'll make that 1, and then if we go from that surface to there, we've now got a height there. And the thing with dimensioning off a datum that's useful is in this case it probably doesn't matter, but we don't perhaps know. But the plus or minus, or the tolerances that are applied to each dimension can stack up and potentially cause a problem. So if we dimension from that datum face, then that isn't going to be a problem. It's not going to matter. Okay, so we've got a center line there, so that indicates that's on center. Probably doesn't matter if it was slightly out. I think on a general tolerance that would be okay. So if we were out by, we're not going to be plus or minus 0.5. The size indicates that it's supposed to be reasonably accurate. Yeah, I think that's probably sufficient. So this hole, now the pin does have to fit through there, and we wouldn't want that to be too loose. So the pin is possibly going to be 20 millimeters less something, so probably 19.95 nominal. So we'll make the hole, and we'll use a hole base fit. So if we add a tolerance on there, we'll call it a bilateral tolerance, and we'll say plus 0.05. And minus nothing. And where's Mousey gone? There he is. Right, so we need to change the display so that it allows that to be visible. Okay. So is there anything else on here that's important? Probably not. I think that those are all our critical dimensions. So we can now get on and balance the rest of the dimensions around the part. So that's one we need. If we put a center line on here, what's happening here? Then putting a width on there indicates that that is on center. So we'll do that. Oh, I ended up with, oh, I've got a center line down through there as well. Doesn't really matter. It's not really that visible because we've got the intersection line of the radius as well. So yeah, I think we'll just leave it like that. So dimension the width. This has got quite a, it's got a radius all running around it, so it's quite tricky to make sure that I grab the right points, and we've got a radius here, and probably the easiest way to pick this one is off the corner. So that's just like a chamfer all around, just a radial chamfer all the way around the product, just to make it smooth. It's effectively taking the sharp edges off, but in a bigger way. And because this is everywhere, we'll just edit that and we'll say typical. We could put R5 two places here, but it's pretty obvious that if that's R5 and that's not dimension, that it must also be an R5. So yeah, I think that that's sufficient. And then we've got the detail around this slot that we need to manage. So 4mm. I'm going to have to rearrange things a little bit here because things are going to get too busy. Because we need to indicate the width of that chamfer. And that chamfer is actually, it's important that that is 4mm because 3.5 will probably do. It's a 3mm radius on the tongue, and you wouldn't want that to conflict. But when I made the parts, I thought about that and made it somewhat generous. That could be 5mm and it would still be quite effective. So where you don't have to put a tolerance on, where an open size will fit, I've said it before, but it's good practice to make things as cheap to produce as possible. Okay, we've got our 45mm and 45 degrees in there. That's probably sufficient. Put a dimension on that radius. And that radius indicates the width, because if that's an R25, this must be 50mm across, so there's no need to add the 50mm dimension. So we're fairly close to being finished. Just one more thing that's required. So we've got a counterbore here, and we can say diameter 20 and times 1 deep, and it's getting a bit long. Okay, I think that's fully dimensioned. I don't like that centre line on there, but no, it's sort of correct, so maybe we'll leave it there. Alright, so just to make things somewhat realistic, we should really give it a title. So we'll call it Clevis Mount. And revision 1. And machine all over. Most drawings have a number. I'm going to quit out of that for a moment, tidy that up. Tidy that up. Then, who drew it? Now that's got to fit down in here, it's not going to. So we'll just drop the font size down to 8mm. And my little title block here is not too useful because fitting a date in there is going to be pretty impossible. So if we go edit sheet format, no. think that's probably superfluous line, so we'll get rid of that. And add note. Okay, I think we can call that finished. Needs to be made out of something, doesn't it? So okay, that should be sufficient for this part. So what we've got, just to reiterate, we've got a 57mm set of centres for two 10.5mm holes. They're quite important, they're on a centre line. In actual fact, probably isn't indicated at this point that those are on a centre, on the centre. So probably should put centre line in that orientation as well. So yep. So now it's pretty clear that those are on centre. So hopefully that's useful. This drawing I don't think would lose too many marks at marking. It's complete, all the information is there. We could make this part from this, and the dimensioning is from a datum where appropriate. So hopefully that's useful.